My name is Jonathan Swanson. I'm a director of security advisory at SentinelOne, and real excited to do this panel. I've done this panel a few times in a few different versions at Satellite over the years, and I always like to start with kind of an audience question. I've asked this last year, and I'd like to know if it's changed. When I say the word Volt Typhoon or Salt Typhoon, show of hands, how many people know what I'm talking about? Okay. What about Advanced Persistent Threat, APT? Anyone familiar with those? Okay, a few more on that. All right. A little concerning that not more people know about Volt and Salt Typhoon, but we're gonna teach you about it, I think, a little bit today. So, while we know that space has become a key economic driver for many countries, it's also become the latest battleground for spacefaring nations. During this panel, we're going to explore that battleground, diving into threats faced in space and how those threats are overcome or defended against. The battleground is populated with numerous types of players, some of which we have representation for today. Operators who maintain these systems and services for their customers, suppliers, manufacturers, integrators who design and build the space assets and the various components that make them up, defenders who are responsible for maintaining the integrity and resiliency of these systems, and capital allocators who help drive the innovation to maintain an advantage over the adversaries. Each of these play myriad roles in mitigating and identifying these threats. And since our last satellite show, we've continued to see a flurry of activity in this warfighting domain. We've had reports of state-sponsored hacking of critical infrastructure, espionage, multiple nations being reported on as advancing their attack capabilities in space, continued ground-based attacks, and on satellite service and support of regional conflicts, right? We've seen a lot of those in the Middle East and Eastern Europe. So with that, I'd like to start by letting our panel introduce themselves. But I'd also like to have everyone kind of open up with a question. And if you're in the fireside chat, you've already heard this question today. He stole my fire a little bit. But panel, please introduce yourselves. We'll start with Troy. And let me know what keeps you up at night.
Okay, thanks, Jonathan. Hey, everybody, I'm Troy Brashear. I'm a vice president for satellite missions business unit at Northrop Grumman. Located here in the Washington Dulles area, I build with my teammates most of the satellites for our company. So we build a whole host of geosynchronous satellites, low Earth orbit satellites, highly elliptical orbit satellites, and we do those for U.S. government customers and also for commercial customers around the world, and I'm going to be excited to talk about that in a few minutes. It's a great question, what keeps me up at night? And as I was thinking about it, and I was making my list, and it all sort of revolved around one word, and that's slowness. All of us moving too slow is what keeps me up at night, and whether that's policymakers moving too slow in deciding how we're going to operate from a policy perspective, doctrinally, how are we going to operate in space with an adversary, moving too slowly there, budgetary decisions, prioritization, what programs are we going to choose to go after as a nation, that worries me that we're going too slow, modernization, technical innovation, moving too slow, all of those things worry me and how we can respond faster, because right now, if you look at the data and our adversaries and the number of satellites that they launch and the capabilities they have, it feels like they are inside of our OODA loop. And so for me, slowness is the word that keeps me up at night.
All right, thanks, Jonathan. So, morning, everyone. So, my name is Nick Goddard. I'm Director of Operations at Navy Cyber Defense Operations Command. So, our role is to defend the entire DoD Information Network Navy, both on the unclassified side, the secret side, and nuclear command and control. So we have about 250-ish networks that we both cloud native and non-cloud native, hybrid, everything that you could think in the middle between a legacy network, terrestrial-based networks, microwave backhaul. It essentially goes from the seabed to geo. And so when it comes to anything that has a network connection, that's what we're responsible for. That doesn't mean that we have the visibility that we need, but that's essentially our mission set. So I work for U.S. Cyber Command, General Hawk, and then also the Chief of Naval Operations on the Navy side. So our goal is to provide not just an advantage in space. It's in order to understand a threat, you got to be able to see the threat. And so you can only defend what you can see. And so when it comes down to that, the thing that really comes to mind as far as what keeps me up at night is the lack of knowledge in the commercial sector from what we have on the government side. And so right now, my infrastructure currently sees anywhere from 8.4 to 8.6 billion events every 24 hours. And so when we stream through that, the threat itself, we're getting better at classifying and characterizing, but sharing that information with the commercial industry is a problem. It would be super useful if I could actually share what that looks like. And when it comes to peer actors, they are not near peer. And I'm specifically talking about the People's Republic of China and the Russian Federation. I have zero issues in understanding and sharing what those threats are with the larger team, and I'm hoping to uncover a portion of that during this morning's discussion. Thank you.
Thank you, Jonathan, for organizing this panel. I'm Lisa Hinke. I'm the Vice President and Chief of Technology and Innovation for our Maxar's USG business segment. I've been in the aerospace industry 35 years, either as Air Force or as a contractor, and I've had the privilege of working with government and commercial systems from the idea insemination, development of a program, fielding, and even decommissioning of those. I'm really proud of the work our community has done over the years, but one of the things is that it always takes a long time, and I think that we're hearing that on this panel. I have an anecdote from my daughter. She grew up with me as I grew up in my different career roles, and I was working for a large defense contractor, replacing defense support program. That was the first program I worked on in the Air Force. And I was explaining the mission to her, and she said, "Isn't that what you did before?" And I was like, "Yes. Aren't you done yet?" And the thing is that the threat is always evolving, and when the threat evolves, the mission needs to evolve to meet it. So I'm with Maxar. We are a geospatial company, the different Maxar. A lot of people know about Maxar Space. We're Maxar Intelligence. As of February 4th, Maxar Intelligence has launched all 6 of our Legion satellites. We have 10 satellites in orbit today, and that allows us to triples our capacity for 30-centimeter class imagery. And we can collect more than 6 million square kilometers a day with a 4-hour mean time to access. And Legion is actually in something called mid-inclination, and what that does is gives us greater temporal diversity, allows us better access in regions such as Indo-PACOM, which are pretty important. And we are a trusted partner to the U.S. government around missions such as Advanced Geospatial Foundation and Constellation, and a virtual constellation, which I'll talk about a little bit more later, accurate 3D representation of the Earth, advanced analytic products, and space domain awareness. So space and space security is critical to the geospatial industry, and there's a lot of work to do. So I know this conversation is going to be a great one. Thank you.
Thanks, Lisa. Garrett?
Hey everybody, my name is Gareth Keane. I'd like to say thank you to Jonathan and the organizers for inviting me along today. I am a partner on the investment team at a firm called In-Q-Tel, based in Menlo Park in California. In-Q-Tel, for those who don't know, we are a strategic investor. Historically, 25 years ago, started with roots in the intelligence community, but have expanded since that time to work closely with the IC, certain parts of the DoD, and some of the US's very trusted allies overseas. Our mission, like I said, strategic investment. We invest in technology and innovation that is designed to secure the resilience and security of the US and its allies. We invest across a number of different themes, but lots of intersection with our topics here today around the areas of space and cyber. My background is engineering and hardware, so I spend a lot of time looking at complex systems and the microelectronics supply chain. And if I had to think of one thing that I'm super scared about, I've only been in the seat at In-Q-Tel for about 6 months. It's my first time working this tightly sort of enmeshed with government agencies. I would have said speed, Troy, but you took my thunder. So I'm going to go with supply chain vulnerabilities. I've worked in the microelectronics industry in my professional engineering career, transitioned to investing in that sector. I think it's frightening to me how many single points of failure there are for anything we build, which is complex. So that's one thing I'm pretty concerned about. And I think cyber intrusion into that supply chain kind of happens all the way along. So.
Awesome. Great. very broad set of backgrounds up here, which is exciting. So I usually like to break this conversation into two parts, starting with understanding the threats, who they are, what their objectives are, and then talking about how those threats can be overcome or mitigated. So Nick, we'll start with you. I mentioned Salt Typhoon, Volt Typhoon in the beginning. You alluded a little bit to who those adversary groups are, but maybe the audience isn't totally familiar with the level of access that these entities have already gained into critical infrastructure. So maybe you can talk a little bit more about who they are, what they're doing, what they're interested in, and why space is an attractive target to them.
Sure, absolutely. So my background, so I've been doing about 15 years of offense before I came over to the defensive side. So breaking adversarial systems was my primary job. And then you come over to defense, and the problem set is infinitely more difficult. One, because you have patchwork networks that are just holding on most of the time in order just to make your email work. And the challenge I run into is most folks don't understand cyber. How many people in here are comfortable with the word cyber? Yeah. All right. A handful of folks. Okay, cool. Going to try to unmask a little bit of that for you and not make some nebulous, your cyber IT nerds in the corner, and you just usually tell them to shut up and color. You should probably listen to them. And so one of the things I like to highlight when it comes to nation-state threat actors, the best defense is a really good system administrator that is backed by corporate leadership that actually supports them. Because every company has intellectual property. Every company has their own secret sauce that makes them work or that gives them a competitive advantage, that files things through like the patent office. How many people in here have patents within their companies? All right. There's a reason why I'm bringing this up. So when it comes to the attack surface, when we talk about the Typhoon series, right? So those are Microsoft identifiers for the People's Republic of China. There are many threat actors from these nation states. They are state-sponsored, right? And so when it comes down to who the threat is, everyone knows who the threat is, but for some reason people are uncomfortable saying it in public. I don't really have that issue. So when it comes down to what the threat is doing, they don't play by the same rules we do, right? So when you're at home, when you're VPNing into your corporate network, you're using credentials to get inside your network. And if you have a poorly architected network from a trusted side versus an untrusted side, you actually pass your credentials through that network. How many people have updated their router at home recently? Anyone? We got one. How many people bought a router and just, it sits there and it works until it doesn't work? Yeah, you guys should probably fix that. All right, so the number one thing you could do to actually defend against some of these threats is have new stuff. Constantly updating your software. Go to Best Buy after this week. Buy something newer than 2012 that you have sitting in your living room. That's important, right? So most people, remote from home is important. So when it comes to the Salt Typhoon, Volt Typhoon series, credentials are really important. So who in here has heard living off the land? Anyone heard of that technique before? That's essentially hijacking a host process and looking like a typical process on whether it's a Windows laptop, a Windows server, a Cisco device, a layer 3 routing device, or other. So all they're doing is taking advantage of how you connect to your network. That is how they're gaining access. So things like principle of least privilege, which is like cybersecurity 101, even senior executives have no idea what that means because they just need to send an email to somebody really important, like a strategic investor, over an SMS message. Why would you do that, right? Or, hey, let me go ahead and text my wife the water bill password because I forgot it. Please stop doing that, right? So your credentials are how they take advantage of targeting you. When it comes down to critical infrastructure, guess what? Humans sit on critical infrastructure. So the challenge from the past has always been about exfilling information so that way they can either, one, prop up their ability to compete and steal your intellectual property, fact. Many of you have probably been victim to that without actually knowing it. The patent office and others are not 100% secure, right? So your intellectual property is what they're targeting. And the reason why is because the government, right, for us, the only way we win is with the defense industrial base. That's how we work since 1945, right? We've had this massive system. So when it comes to bureaucracy, that tends to be a challenge for identifying a threat. We know what the threats are. We know how they're maneuvering into those networks. But the challenge is trying to get corporate America to listen and say, just invest money in your IT department to have a really good network, and then you won't give them access to our core. So instead of stealing information, it's changed in the last few years into pre-positioning into our networks for actual cyber effects at a time of their choosing. Can you imagine a day before we have a conflict, and then all of a sudden power, water gets turned off, right? To you, the average American that isn't part of the government, you're like, I no longer have my services. So how much trust do you have in our government to defend that, right? So our center of gravity is how the American public thinks. So our ability to defend the defense critical infrastructure is easy. I can still wage war, but the American public is the reason why we tend to lose the advantage because we can't give you the level of confidence that we should. And I think that's been part of the challenges to identify these threat actors going after living off the land, stealing your credentials, and using them in a way that is surreptitious to whatever network you're attached to. So whether you're at home, on your cell phone, sending emails to your friends, you may have the best IT department in the world, but when you go home, pretty sure you don't take your IT department with you. And so your bad habits allow threat actors very easy access into your own corporate networks.
So, Nick, you talked a little bit about, some of the traditional, cyber attacks, what they're interested, why they're interested, pre-positioning. Troy, let's kind of move to you. Are there other threats that, beyond what Nick talked about, that your team is working on and identifying and mitigating?
Yeah, let me first start out by saying, Nick, that was fantastic. So thank you for sharing that. And maybe it makes you feel better or not. So my wife worked at Cisco for 20 years and did a role like yours in the Air Force. So I'm not allowed to touch the router at home or any of the stuff at network at home. So she's got that taken care of, but I don't touch it. Hey, those are really serious threats that are pervasive across, I'd say, all of our systems, and whether those systems are land-based or sea-based or underwater or geosynchronous orbit, those are certainly real. For an organization like mine, focused on geosynchronous and low Earth orbit and highly elliptical orbiting satellites, I like to think back on General D.T. Thompson when he was the vice chief of space operations. And he talked about the other threats that are way heavy on him, and some of those being RF threats that are coming from the ground, attacking satellites, laser targets. And the Space Force in the United States has seen an increase in those attacks, right? We've clearly seen that from the Russian Federation, especially in this Ukrainian war period. And so those threats are really worry me, because a lot of our satellites, right, we designed and developed and built in an era that was maybe slightly before we all really understood the true threat. So now we're trying to understand how to incorporate those threats into our systems so that we can mitigate the threat and potentially counter it. I also start to think out about cislunar and where adversaries are going from that perspective, and what that might mean for our civil and national security space programs, and that's from today's threats on your cell phone to a cislunar threat, right? It's a huge continuum, but I think the thing that's constant about that continuum is that it's present, right? It's not far out into the future, and I think those are the other things I worry about.
Cool. Thanks, Troy. So we've talked a little bit about what these threats are, pre-positioning, and when we talk about space and cyber, space is cyber, and we typically talk about those traditional type threats, but it's not just a cyber battleground, right? It's also a physical one, and this is becoming more apparent and more important, with nations deploying anti-satellite capabilities. You mentioned some of those co-orbital threats. Unconventional means of interference. So Lisa, let's talk a little bit about, as the space domain grows more complex, with all this new activity happening, what are some of the indicators or intelligence methods that are being used to detect some of these threats before they become an issue?
Great, thank you. So space security and space domain awareness are foundational to homeland security. The American way of life depends on space. I would bet none of us arrived here today without using a space asset, whether it's GPS navigation, or in my case, my home network is Starlink, because I live out in Northern Virginia and I lived in the digital divide before there was Starlink. So that's how I accessed all my information about where I needed to be today. So space is just foundational to our way of life. Well, not a space problem, but a cyber problem, the Colonial Pipeline shutdown in 2021 demonstrated how fast our society degrades when our way of life is disrupted. I was driving out on the roads and people were like 4 lanes of traffic across to get to the gas stations. So I think a lot of it goes to how do you assess a threat in space? Territorial boundaries don't apply when you're in space. When is proximity a threat? And it comes down to building an awareness of what is normal behaviors and when things have deviated, and getting better characterization of space objects. So one of the things that Maxar has been working on is commercial non-Earth imaging, or SAT squared. A few years ago, I would have thought I was going to be arrested for saying that in this forum. And you might have seen some of the images we've taken of the International Space Station. And so we are taking that and applying it to better characterize what is the threat. And sometimes, this is just what is the behavior. There's been some transporter launches where multiple satellites are released at the same time, and there's trouble distinguishing which one is each carrier's satellite. And so we are able to work with those companies to say, this one looks like yours, right? So try and make contact with this one. So this capability is increasingly important as space proliferates. Since 2015, China has launched a lot of satellites. They had 950 last year. 470 of those are ISR, like our satellites. And we know this is going to continue to increase. March 5th, there was 11,833 satellites in orbit, and it's projected to be 30,000 satellites in orbit in 2030. So not just people who are intending to do harm, but the unintentional harm as well. So really understanding what is normal, having awareness of what is happening, and being able to characterize those threats is going to be critically important.
So the physical threat is real, and it's more real than it's ever been, right? With orders of magnitude greater. So Troy, we're seeing advancements in on-orbit servicing, refueling, satellite life extension, more physical things happening in space, which wasn't something we were talking about in previous years. So from your perspective, how do these improve resilience against space-based threats? And can they be leveraged to counter disruptions, from adversarial actions?
Yeah, great question. Maybe just, excuse me, just ask the audience here real quick. When folks think about the idea of taking a satellite and having it go into orbit and maybe affix to another satellite and help extend the life, or maybe do a repair, how many people would find that a pretty exciting mission? How many people know that we've done that for like 5 years already? So exactly 5 years ago and a few weeks, Northrop Grumman, via the Mission Extension Vehicle, attached itself to an Intelsat satellite and is extending the life of that satellite. It's been on for 5 years now. And so think about the capability of a satellite for whatever reason, right? Whether it's running low on Delta V, whether it's had some sort of orbit issue, and to be able to attach yourself to it and extend the life. We've done that twice, once 5 years ago and once now 4 years ago. So it's not a futuristic capability, it's a today capability. To answer the question about what it means, I mean, for me, and I spent 23 years in the Air Force in what was space, before there was Space Force, doing operations and acquisition. And to me, to think about having the ability to take a DSP satellite, right, a legacy satellite still performing a wonderful infrared mission with a great payload, and extend that life for another 3, 4, 5 years, while militarily there's a replenishment program going on, right? If one satellite is taken out in a kinetic attack, we could extend the life of one vehicle while we're ready to launch others up there. So I think from a sort of backup replenishment perspective, also from a making the enemy's calculus a little bit harder. And I'm going to talk a little bit about that when we talk about commercial partnerships later. But that's militarily, that's what you want to do. You want to make the enemy's life harder. And in this case, harder means harder to target, harder to attack, more things to have to attack, right? Interacting with commercial and foreign companies makes it harder to attack. So things like Mission Extension Vehicle, our upcoming mission robotic vehicle that could go in and actually make repairs on satellites that need it. All of those, I think, have a significant commercial aspect to it, right? It greatly helps a business case if you can extend the life of a ISR satellite for 4 more years. Companies like Maxar can pull further product down, sell those products, not having to recapitalize a new satellite system in order to do that, saving hundreds of millions of dollars. And then there's clearly a national security part to that, right? To be able to extend a vehicle trans-conflict, pre-conflict, post-conflict. So really excited about that capability that a company like Northrop and others are trying to bring to the marketplace.
All resilience. So continuing on to our deep dive on specific attack vectors, I want to talk about one of the most disruptive and widely used forms, satellite jamming, right? We've seen it in regional conflicts, whether it's targeting military operations, commercial aviation, emergency services. It is a key tool in modern conflicts. The reports of GPS interference have surged. A sharp increase in deliberate jamming incidents. It's played out in Ukraine and other regions as well. So, Lisa, given the increasing sophistication of jamming techniques, what advancements are being made to overcome GPS and navigation disruption in real-time operational environments?
Great, thank you, Jonathan. I'm going to focus a lot on drone and GPS denied nav for drones. There are multiple solutions out there, RF, radio, visual navigation that are being employed. And solutions are generally combined to have a more resilient platform, right? So if one's not working when the drone's flying, you can fall back to the other, or that they can share data back and forth from a fusion standpoint. So one of the things that Maxar has done is used our global 3D datum that we've built. And so that provides 3-meter SE90 accuracy around most of the globe. And it allows vision-based positioning and navigation, geo-registering the software to that foundation. So the drone camera's full motion video is actually registered to that unique 3D terrain, and that provides the aerial position, and you're able to extract where the drone is. And we can even deliver coordinates to the ground in near real time. So it's designed to be lightweight and operate on any UAS platform, and can operate without any GPS information. A lot of the GPS denied nav solutions require that they at some point had GPS, and this doesn't need that. So it's actually 3 different products. One is a Pinpoint 3D guide, and so this actually is on the drone, and it does, while the drone is flying, does that registration. And then there's Precision 3D Sync, and this uses our proprietary algorithm to register the data that's pulled in from the FMB to the ground, and you're able to extract targets from that. And the actual extraction of the targets is called Pinpoint 3D ACE. And so as far as the maturity of these, we have demonstrated guide in flight tests, and we actually are doing one in North Carolina. 3D Sync and 3D ACE have been demonstrated in operational environments and had great success. So I think that they're all new, right? We are trying to solve the problem, and I like the idea that companies are coming together with their solutions to solve the problem.
So it's interesting, taking a threat to a space asset and saying, we're just gonna use what's on the ground. We don't need it. We don't need what's up there. We're gonna use a ground-based solution. So speaking of solutions, so Gareth, what other alternative, PNT solutions or other anti-jamming techniques or anything are you seeing in this space?
So it's a great question, and we're a pretty active investor across all kinds of alt PNT solutions and that entire solution space. I think one of the challenges is anything on the sort of RF update, sort of anti-jamming in the RF domain. As soon as an adversary updates their EW libraries, it kind of that sort of avenue goes away, unfortunately. So we've been looking at solutions with approaches like IMU or sort of inertial motion sort of sensors. We are actually an investor in a number of alternatives or sort of enhancements for the traditional GPS system, including some LEO-based constellations, which are trying to build essentially more resilience and sort of additional signal that a sensor or a receiver could use to kind of help to maybe punch through some of that noise. Innovations in areas like photonics, innovations in areas like quantum sensing. These are pretty out there, but areas that we're continuing to invest in and trying to find solutions for our partners.
And how far along are we to some of those newer solutions? Are some of these out there already? Are a lot of them still in the R&D phase?
So we've had actually one of our investee companies partner, one of our agency partners, to do something interesting around a photonics-based solution for sort of inertial tracking, and that seems to be quite promising. So yeah, we're seeing stuff come to maybe not full commercial market yet, but certainly for very bespoke, very specific, very mission-critical use cases.
So are these primarily military, or do you see dual-use opportunities?
Everything that we invest in, we're keen to see a commercial roadmap as well. So we would see these being deployed in dual-use capabilities for sure.
Great, thanks. So, I want to talk about public-private partnerships. So, as everyone knows, space infrastructure is built, maintained, operated by a very complex web of people, organizations, nations, government partners, and no single organization has ownership or control over the risk landscape. It's kind of a shared responsibility. And so, it poses a number of questions, right? Who is responsible for securing what? How do we align security priorities and policies between public and private sectors? How do we build trust when we're working with international allies while protecting sensitive technology and intellectual property? And I think, Troy, you've got a good example of how we can talk about this. So you guys recently partnered with the U.S. Space Force and Space Norway on the Arctic satellite broadband mission. Can you tell us a little more about this program and how your team approached balancing security implications between multiple international partners?
Yeah, super excited to talk about, we call it ASBM, Arctic Satellite Broadband Mission. And let me talk real quick about, I spent 13 years of my life as a youngish guy, captain, in essentially the North Pole, inside the Arctic Circle at what was then called Thule Air Base. Big radar station, looks over the Eurasian landmass, looking for any missile launches. No missile launches on my watch, by the way. But it also tracks space objects, was that mission. But living there for that amount of time, Arctic comms is hard, right? Just think about it from just a orbital perspective, right? From geo hitting the top or the bottom of the Earth is very, very challenging. So Space Norway, obviously, given where Norway is, needs access, better access, more reliable access to Arctic communications. So this program was born several years ago, and it's just fantastic if you think about it. So Space Norway, which is a company inside of Norway, partnered with the Norwegian government, partnered with Viasat, putting a business case together to put 2 satellites, highly elliptical orbits, so they hang over the North Pole in these 12-hour orbits. They're alternating, so one is always on, at apogee, the other's at perigee, and to provide that sort of communication. But several folks had this just foresight to say, what can we do? How can we partner together with Norway and the United States? And so what happened was, the United States ended up putting a classified communications payload, let me say that again, a classified communications payload on a foreign satellite, a Norwegian satellite, on a commercial satellite, on a Space Norwegian satellite, and they're in orbit. We launched both of them last year. So you think about that, right? A classified payload on a foreign commercial satellite, and we did that from a security perspective, and that actually wasn't the hardest part, right? We have this Alcatraz-like delineation of the payload and the data that goes down, so there's no issue with any sort of data leakage either way, right? And it has a commercial aspect to it for Space Norway. So just a tremendous opportunity. I want to circle it back about to a couple points, right? One, if the U.S. Space Force has used this in their public announcements, the fact that just putting that payload on this system saved them $900 million. That's an incredible number. And if you think about it, it actually makes a whole lot of sense, right? Because you didn't have to procure 2 satellites yourself. You didn't have to get the launch vehicles. You didn't have to provide for all the So just that amount of savings and that collaborative effort is tremendous. And it avoided all that opportunity cost. That's $900 million that could then be applied elsewhere in space or something else the U.S. government wanted to do. But what it also did, to circle back to another question, is, again, it makes the enemy's calculus harder. Because now if you're the enemy and you want to attack this U.S. government communications payload, which is, okay, that's fine, that's on your target list, but are you also targeting Norway now? Are you also going to attack Norway at the same time you're attacking the United States, because it's on the same satellite, on the same system, sharing the same power and infrastructure? So again, from a national security perspective, amazing to make the enemy's calculus just a little bit harder, and right, and just a little bit, that incremental toughness is just great. But also from a business perspective, right? These hybrid relationships that we can put together with commercial and government on the same mission can help businesses close business cases and can save governments a lot of money. So we think that this is a way forward for all of us to partner with nations, groups of nations, militaries, and commercial entities to put capability into space.
So a very successful, more than public-private partnerships, but a lot of partnerships there, a lot of trust, but a lot of controls, a lot of mitigating factors there. I want to turn it around to look at what maybe some of the opportunities are, and Nick, maybe you could speak to this from a government perspective. Where are the biggest gaps where we see public-private collaboration when it comes to securing space infrastructure? Is there more that the government can be doing to set standards, or is it the private sector's responsibility to take the lead there?
Thanks, Jonathan. I think it's a combination. One of the challenges we face here in a few months, everyone will be really excited for direct-to-device. Everyone familiar with direct-to-device? So what does that mean? I think abstractly, there will be no more denied territory in this world. Right? Just want to make sure people understand that. We've been talking about gaining access to adversaries' infrastructure, and other folks using the publicly facing internet. You carry around the most powerful supercomputer that's ever existed in mankind in your pocket, and it's now connected all the time. And so how much security do you trust the mobile telcos and the other companies from a software standpoint? Right? So when it comes to integration, most companies want to save costs by sharing infrastructure. Sharing design requirements with software, typically a bad idea, especially when it comes to integrating, right? So the challenges that we face is when we buy something as a service that's either commoditized or we own it. When we own it from a bespoke nature, that becomes a problem because we can't usually modernize fast enough. But when we buy it as a service, we trust everyone in this room to sell something that is not going to be, insecure. Well, that's not real, which is why we have zero trust. Right. So as an example, from a software standpoint, when it comes to the gaps, I don't have to target the space domain when you're using common ground infrastructure. Right. So I go to a teleport, I go to a gateway. It doesn't matter where you're at in the world. That has poor cybersecurity, poor software chain integration, and I don't really need to worry about your $10 billion satellite in GEO. I just do a denial of service on your ground infrastructure, and then that satellite is functionally useless. Right. So when it comes to cyber, I was here last year at that show, and I spoke to 54 different vendors over the course of a day and a half. And the number one thing I heard was, "I'm just transport." It's like, no, you're not. You are migrating threats into our infrastructure because your P&L statement was, "Hey, that's somebody else's problem." Right. So when it comes to a gap, unsexy things like software bill of materials. Where is your software developed? Where does it sit? Oh, I just hired somebody in Europe to write it for me. Oh, that's good because it's no longer your software, right? And so you park that on a U.S. government asset and you write it on a list, and the government isn't smart enough to really understand where your software is because we didn't ask that question and you didn't offer it to us, right? So when it comes down to transparency, what are we actually buying? I'm not worried about what's on orbit because that's a really hard problem. In ASAT, kinematics alone by itself, that takes a whole bunch of rocket scientists and a whole bunch of aerospace experts to be able to sort that out. I can get a script kiddie to go after a poorly architected ground infrastructure and just shut it down with a botnet. That's really not difficult. So when it comes to RF, so RF and TCP/IP are the same thing. It's just different mediums. A denial of service attack in space looks like electromagnetic warfare. I always joke around, EW is the old cyber, right? So when we talk about denial of service, it's the exact same technique. Whether it's an Ethernet cable, microwave backhaul, RF between S, X, KU, KA, it doesn't matter. Those are all protocol-based systems. And when you have a protocol-based system in orbit, guess what? Once you put it up there, it's very hard to change it unless you're using things like software-defined wide area networking, or you're able to change the infrastructure on the spacecraft. So trust is really what it comes down to. Encryption is not good enough because we have poor software integration, right? So MVP, minimum viable products, right? Let's push it out. It was designed to get out crappy software fast, and then we'll fix it later, right? And so when you think about iterating quickly, sometimes speed is bad, especially when you don't know what you're buying. Oh, I needed it yesterday. Cool, you've just accepted 2 different risks you just didn't understand until it's too late. And so when it comes down to partnerships, what we think about in space is how do I reduce the attack surface? So one of the things that the U.S. Navy is doing, we've partnered with Rivada Networks, we've partnered with Assured Space, we've partnered with Tachyon Networks, Rampart Communications. So the companies that we talk about, how do I remove the ground infrastructure? I don't want to touch the ground ever. I want to go straight to a spacecraft, on board, maneuver anywhere I can down to another unit. I don't care if that unit, so typically most people in Navy, some of the folks might have heard it, but when you close your eyes and you think you're Navy, what do you guys think of? Floaty gray things, sinky black things, flyy gray things, right? But the Navy itself, 90% of my attack surface is ashore, right? Force generation. Being able to produce, move ordnance, move things that kill people and break things into a place where I can actually launch it. Guess what? When we launch these high-end weapon systems, guess how they're talking? Space, right? So everything has a cyber component to it. So when you think about security, cybersecurity is almost always last. It's a compliance game, right? It's really, so the Navy has gone from thinking about how to secure a network to how to secure the data. Not all the data has the same value. And so what does that look like in real time? So if I have a weapon system that is designed to blow up, do I want to spend $100 million on developing a really fancy receiver that no one can see? No. I just need to defend it long enough for that 38-second flight time for it to arrive on target, right? But I need the infrastructure to be able to be resilient. And that's a word that have lots of different meanings, even amongst the services. And so for us, in order to assure our command and control, we need transparency from both vendors and then also government asking you very technical questions and then also giving you threat. If you do business with the U.S. government, does anyone know what you guys get for free? Anyone? Besides a lot of paperwork. Right? You get a $4 trillion intelligence apparatus. Why don't you use it? Ask us hard questions. We should be providing that to you. And not on a quad chart that is at a classification that's irrelevant. Right? We are partners. You are part of our warfighting ecosystem. And guess what? If it's secure enough for the U.S. government, wouldn't it be useful for banking? Wouldn't it be useful inside your own networks? Would you want co-developed use cases? That would be super useful, right? So we are not asking you to develop bespoke things. We want commercial to be success. That's how you guys have outmaneuvered and out-innovated all governments, not just ours, right? The advantages you see is because we're not limiting you. Don't give us too prescriptive networks. How about we give you problems from what we see from a threat actor instead of you wasting time on solving every single vulnerability in a system? If I gave you the playbook of an adversary, would that be useful? Probably. That might help your CapEx over the next 3 or 4 years. Might be super useful in a classified context. Ask us those questions because guess what? We have those answers, and we want to provide that. So the public-private partnership is about government being better at sharing information we have, and also you sharing information from your engineering teams going, you gave me very vague information and it was super not useful, so I kind of just took my own liberties and kind of built something that we think you want, right? Instead of having, we call it threshold and objectives just because we're lazy, right? Because in reality, we want flexibility and adaptability, because I can't tell you what's going to happen in 6 to 9 months. Right? So for us, the threat is what's evolving and driving us, not the technology that you are developing. So that partnership should be very useful when it comes to trust, because we're in the communications business, which is trust for everyone. So please allow the government to assist you in understanding what those gaps are.
So it's two-way street, and there's more opportunities to leverage the government where organizations aren't. So I've got one more question, and I want to leave time for questions from the audience. So we'll get through this one in the next 4 or 5 minutes or so. Nick, you bring up a good point about the supply chain. And whenever I come to this conference, I'm always fascinated by all of the very niche suppliers that are here, right? Some are making components, some are making transceivers, some are doing software development, some are, all these different organizations that, end up in, one bus or one satellite. We often think directly about the physical components, but I think another point you touched on, and I want Lisa to speak to this, is the data supply chain. And so, Lisa, I would imagine that, the data that you guys generate, transmit, procure, goes through a number of different points along the data supply chain. But how, what are the risks of that data supply chain, and how do you make sure that that data has a level of integrity that's appropriate for the mission level, capabilities that you're developing?
So Nick touched on a lot of the risks to that supply chain, right? There's going to be the direct attacks, the cyber attacks, the desire to disrupt the data flow, the desire to change the data inflow. So I'm going to talk about this in actually two forms, right? So talk about something called a virtual constellation. So Maxar has 10 satellites in orbit that we downlink that data and we process it. We're something that's called a secure provider. We're actually the only commercial secure provider that provides imagery data to the United States government. And that means that we went through a series of checkpoints that looked at our space and ground assets, how we protect those space and ground assets, our cloud capabilities to make sure they're uncompromised. We also have to have a secure posture within our own company for our own software development that processes our data. And we conduct regular threat and vulnerability assessments. In fact, security is actually built on. It's not something that we try and put in at the end. It is considered upfront as part of the design, even with our MVPs and our rapid prototypes. We also make sure that our people comply with policies. And those policies include insider threat, but also secure supply chain. And so this is where I want to talk about also what's a virtual constellation. So our secure supply chain also applies to the data providers as well. So our virtual constellation partners are vetted. We actually start off with doing smaller projects with them, going after a certain US government mission, say site monitoring in Indo-PACOM. And we work with these providers on these very small things, just buying their data, and we're assessing how good is their data? What's the security of their supply chain? How good are they at responding to us, right? And once we put them through the gates of that supply chain, then we announce partnerships with them, and we've announced partnerships with Satellogic and Umbra, where we can bring the power of all that data together to answer hard intelligence problems. So we're seeing strategic product partnerships like this across defense and space tech companies because we're better together, right? No one company, commercial and even government systems, you're not going to answer the problem individually. It takes everybody working together to go after these problems.
So I like that, and you don't always see that approach to supply chain risk management. It's actually, diving in with a partner and seeing how they do and what their capabilities are. Real quick, I want to kick it back to Gareth. Supply chain risk management isn't a new concept. Everyone here has been doing it for a long time, but I don't know if it's necessarily seen as the sexiest or most innovative field when it, particularly when it comes to the intersection of space and cyber. I guess would you take the other side of that position, and are you seeing or are you guys investing in anything that's new, interesting, or groundbreaking in the space of supply chain risk?
Yeah, I think you could think about supply chain resilience from a number of different lenses. I mean, just the data pipeline, things like tactically responsive launch to put an asset into place very, very quickly, or maybe forms of optical communication to take some of that RF sort of jamming risk out of the equation. Those are both areas that we're excited about, we're investing in. From the point of view of, the nuts and bolts, picks and shovels, semiconductors, I mean, that's a very complex industry, and unfortunately, the US has traded away most of its leadership there from a supply chain perspective. So I think we need to get some of that back, some of that be domiciled domestically. You look at an entity like TSMC out of Taiwan, which probably, I think they say publicly, they fabricate 95% of the world's most advanced chips. I think they're trying to avoid some monopolistic arguments. They probably do 100% realistically. If they go down, all of our consumer devices, most of our government sort of critical infrastructure, very, very challenged. So yeah, we think about that stuff a lot, and I spend way more time than probably my life is worth thinking about things like lithography tools. So, yeah.
So I think that is a question for an entire other panel. So with that, we've got about 9 minutes left, and we can open it up to the audience for questions. Looks like the first hand I saw was over here.
Thanks, folks. I'm Clay Bosler with the Space Systems Command, and this question actually is for you, Nick. First, I really appreciate you pointing out that it's crazy living in this modern world that we're still using security classification that defaults to 25-year requirements for a classified piece of data that may have a half-life of seconds. So we've got to fix that. But you said a really provocative thing when you suggested that MVPs are just an excuse to provide crappy software quickly. Flip side of that we at SSC inflict on the service is a multi-year acquisition, certification, testing process that takes us years or decades to provide an update to basic capabilities. How do we get that balance right? What's your thinking around that based on what you've seen from both offensive and defensive cyberspace? Thanks.
Yeah, absolutely. And actually work with Dean Lenigro at SSC as well to have some other discussions going forward. So I'll definitely loop you in on those. So when it comes to software, so on the MVP side of the house, there are companies that are actually really good at developing software, right? The government is not one of them, right? So when we talk about developing software, we talk about folks who are competitively advantaged, folks like Google, folks like other folks, right, that are specifically tied to software development from an API standpoint or others. So when you partner with those folks when it comes to security, you can do an MVP that is actually useful, sprints that are actually 2 weeks long instead of 6 months long, right? So the fact that the MVP process, so I'm an Agile Scrum methodology expert. I've been using it for offense for quite some time. The reason why we're slow is because we have to integrate on many antiquated systems. That's the challenge, right? So MVP can work when you can violently iterate, meaning moving quickly along with the prototype that you're going after. So why is the government buying old hardware and then maintaining end of life and end of support systems? And we just throw more money because it's easy to keep them going. So we actually don't take advantage of the software ecosystem unless it's a SaaS. I think we finally got comfortable, we being the government, with SaaS solutions probably about maybe 12, 13 years ago. Now we have IaaS, right, where we completely remove the OS itself and we own the portion of that. And then now we have PaaS with containers, and then we get to microservices. But most folks don't understand that because we still have our own infrastructure. So that's kind of the challenge. Partnering with folks who know how to develop software requires an ecosystem that software can ride on. So Kubernetes, perfect example, right? Largely built by the Google team. We have infrastructure that's built with Kubernetes containers in mind. And so what does that mean? We need infrastructure to mount it. Some of our servers are 2009. They don't mount microservices, right? So when it comes to, hey, we tell a vendor, I need you to make it work on the software side with this thing. So the sprint has to work, meaning we'll have to completely test this in a lab environment for 9-10 months and not actually transition to production because our systems are the ones that are fragile. And the new software that's being developed is the solution. But without modernizing hardware, so this is why the Navy is starting to get out of the hardware business on a portion of it, things like Flank Speed Edge for us, as an example. So we use a hyperconverged infrastructure stack, whether it's Dell, HP, we don't really care, tightly integrated with our Azure cloud-based system. And guess what? We leverage a Microsoft. We leverage Google. We leverage AWS's ecosystem in order to take advantage of software that can be developed very quickly in an environment that is well-known, that has well-formed APIs, and that also has a very robust library and ecosystem to help people write code. And please don't, write it on your home networks that are also like poorly defended, right? And so it comes down to where are you developing, how you're developing, and who you're developing it with. So all that we ask from a government side is please, stop subbing things out to other folks that are doing software that you have no visibility on. Is it more expensive to do that? Yes. Is it much more useful for the government side and for your own intellectual property? Yes. A lot of times you should share source code with us because we have the ability to QC it internally. That's the challenge we run into. Proprietary stuff doesn't work with us very much, right? So it's very challenging for me to reverse engineer a source code. I'll just use a perfect example, Avanti. Our whole VPN challenges that happened last year. And they had an old Linux kernel that had a nice, pretty little wrapper around it. That PRC absolutely gutted. And then we found out after the fact, right? Because we didn't ask for source code. So these are the types of challenges. The government just doesn't know enough about software, right? So on the offensive side, we're very good at software because we do a bunch of reverse engineering. We break things intentionally. On the defensive side, I actually don't want things to break. And so I spend most of my time trying to make sure, because we won't do a software push unless we've tested it 1,000 different times because it'll hurt a production environment. And how many people have the money to actually have a digital ecosystem, a digital twin, where we can actually test it on before we push it out? So to answer your question on the SSC side, it's very hard to emulate those space systems that are already on orbit. The ones that are being developed, we can make less bad, but the ones that actually start from the beginning with valid software developers instead of the very small ecosystem that are cleared TSSCI becomes a problem. So having access to more software development companies that are US-based is the only way we're going to be able to fix that, and integrating them into the projects and not expecting a bunch of government civilians to be able to do the heavy lifting, because in reality, I can't pay a software developer $500,000 to do software development in the government. So you get what you pay for.